big anvil strike last night?
I wasn't even out.
Yes, let's talk some about lightning.
Did you get that big anvil strike last night?
I wasn't even out.
So, let's talk a little bit about the lightning then. If you look at this little picture right here, we're just going to kind of look at a general landscape area. We've got a nice cloud up above, and particles inside the cloud kind of rub up against each other, and all sorts of different things going on. You typically get some areas of positive and negative, and most of the lightning you'll see will be in between those areas of positive and negative up in the cloud itself. So you might get a discharge from the negative area to the positive area. So all those negative charges over there move on over, and as a result giving you that neutral area instead of having the split positives and negatives and everything. Again, nature's going to move towards being neutral. So let's take that same thundercloud situation here, and let's say this particular cloud gets a bunch of negative charge all built up down along the bottom of the cloud itself. And so that's a lot of charge, so really large amount of electric field. And so what will happen is those negative charges then will induce a positive charge on the actual surface of the ground itself, and does this by pushing away the negative charges. So it generally leaves behind just a positively charged surface to the ground and anything out there. So baseball field, trees, houses, cars, just the ground itself, everything's going to be positively charged there. So then what happens then is you have an attraction between the positives and negatives, and so let's say the negatives start to kind of leak out of the actual cloud itself, and so the negative charges start to leak out in the familiar form of lightning, and those are what we call step leaders, and typically negatively charged. And so you have negative charges in all those areas, and they heat up the air around them, which causes the air to light up, and giving that lightning. Now, on the ground, you have positive charges, which can move. With this strong of a force, you'll actually have some motion of those positive charges moving up out of the ground, off the trees, off the building, and you get these things which are known as positive streamers. So you have negative charges reaching out, you have positive charges reaching up, and what you look for then is when one of those negatives and positives may actually connect. Here we have an actual image of some positive streamers. So off here on the right side of the screen here is an actual bolt of lightning that struck, but here you can see some little positive streamers that are in the ground around that area. So just like in the picture, we have some of these positive that were reaching out towards the negative charges that were coming down. So again, if we take a look at the process then, if the positives and negatives actually connect with each other, then you have a sudden burst of all these negative charges running down through this conduit, through the lightning bolt that has been created here. So all the charges then will just simply run all the way through, in this case through the tree, down into the ground, making a neutral result in the ground itself. So here's a picture of that basic idea there. Here's a nice tree. You can see a positive streamer over here, another positive streamer here. There was one right here, but it's connected through with a step leader, and that charge is then comes straight through the tree here. And even though the tree is an insulator, it really doesn't have much of a chance against the total amount of charges that are coming down out of the cloud. Here's another good image of lightning. This one's actually what we call a positive lightning strike. So this is where positive charges came down out of the cloud. So everything in our pictures that we've looked at so far in the description are just simply flipped. We had a positive bottom of the cloud and a negative ground. And that's why it looks so thick in the picture there, because the positive charges are much bigger than the negative charges. But again, you can see the leaders that are around here as well in this particular image. So let's go back to our original video here.
Even out.
You'll notice that it doesn't hit the tree in the foreground. It hits back behind it, maybe a smaller tree back there or just the ground out there. You can simply see the dust kick up from that. That leads to an important idea here, that lightning does not just hit the highest point. It goes to refer to follows the easiest path specifically. Electricity is going to follow the path of least resistance, and going through the air is a very fluid situation there. So something higher may not be easier to get to than something lower or something even farther away. This next clip right here will show you that idea. This is an electrical relay station for the electricity going through our power lines and everything, and these three sections right here are what are known as switches. Just like you might flip a light switch to turn something on and off, these are switches to turn on and off the flow of the electricity from the power plant to your homes and to our neighborhoods. This particular switch here is not working right, which is why this happens here. So just like when you flip a switch to turn a light on and off in your room, you should not see a spark inside that switch. It should just simply flip on and off. In this case, there was a spark, so there's a problem with the actual switch itself. But what you can see is that instead of going straight across from the 2 points here, the electricity is actually flowing up and out and around this path here, because the electricity that went across to start with is actually heating up the air. When the air heats up, it gets less dense and it moves up through the cooler air, and so as a result the electricity flows up higher and higher, and it's following the path of least resistance. Even though that's a much farther total distance, it's much easier to get from here to there through this path of heated air, as opposed to straight across in that little section between the actual posts there. So here's a quick video of some lightning. It's just charges moving, and this is taken with extremely high speed camera, and as you watch it you can kind of see the lightning branching upward. This is lightning that's coming from the ground, moving out. As you can see here, seemingly the particles crawling through the air almost as you look at it, and some moving much faster, so you get the little flashes and blips. I think it's interesting to see the motion of the charges here as if they're little points moving up through the air in this case. So that was a ground to cloud lightning, which is not natural. It only happens when you have a man-made structure, a good conducting material, in order for the charge to flow up into the cloud. You're going to have lightning in the cloud itself between areas of positive and negative, and you're going to have lightning that comes from the clouds down to the ground. Typically, even if it's positive, it's going to go from the cloud down to the ground mostly. So here's a quick clip of some lightning coming up through a tower. And as you watch it again, I want you to look for the beginning, see what actually caused this to happen. It's hard to see it at first, but what scientists have studied and understand about the ground to cloud lightning is, when you look at it in slow motion off to the right there, you notice this flash out here. So some lightning struck off screen over here somewhere from the cloud down to the ground, and when it did that, it charged, put a lot of negative charge down into the ground at that point. And as it spreads out on the ground, neutralizing and kind of balancing out, kind of like the dye that we talked about before in the water, as it kind of spreads out through the earth to become overall neutral. As it does that, if there's something conducting, over here there's a tower, then you'll notice that charge then can flow back up into the cloud. So the charges that are coming out here are the same charges essentially that came down with this strike over here and moved through the ground very quickly and then back up in this case, because there is a conducting material such as a tower in this case to allow the charge to move back up into the cloud itself. So one last look at our video, our original video. This one is in slow motion again. I want you to notice the quality of the video on this as it happens. I also want you to think about how many times did that lightning happen. Probably about 4 or 5, typically 4 or 5 pulses of all the charge going down through. We don't generally see that, but it generally has pulses of charge flowing from the cloud down to the ground. But you also notice the flickering of the actual video itself here. Alright, and that is because of the electric field that's around all that electric charge is interfering with the actual electrical equipment that's doing the recording, and it's causing some interference there in the video itself. There's an extremely large amount of electric field when you have a large amount of electric charge. It goes pretty far out away from the original source here. So in this particular clip here, we have what's known as a Tesla coil. It's a very large Tesla coil this gentleman has, and he's going to use it to generate some very large sparks of electricity, of electrostatic discharge, essentially lightning coming off this dome up here. Well, what happened there? It's like it's hitting him, but it's not. So what you see here is he's standing inside a metal cage here. He's basically built himself out of a little wire fencing, a little cage to stand in. It turns out if you have a metal container or a metal object, that the charges themselves are going to be blocked by that metal container. It's a good conductor. So the charge is going to flow around on the outside of that metal container and protect the person inside here, in this case, from being electrocuted. The charges are all staying around on the outside, and all the electric field associated with them stays on the outside. It's what's known as a Faraday cage, which protects people, objects, anything from electric shock. And these are in different electrical devices as well. They'll have different little pieces in there that will shield some of the components from outside electrical sources. So we got one last clip here to look at. It's another Tesla coil out here, and in this case the camera itself that's videoing this is inside the cage. You can hear the popping of the sparks as they hit the cage, but nothing's getting into the camera itself. You might notice, looking at that, there's no interference in the video. That's why I just showed you that clip of the lightning, where you can see the interference in the video itself because of the electric field of lightning. In this case, there's no interference coming through whatsoever. You get a nice clear picture because the electric field is being blocked by that electrical cage. And so one of the things that this kind of leads to, as we kind of wrap this up and talking about lightning safety, is we mentioned that lightning can travel great distances. I mean, sometimes 20 to 25 miles from where it leaves the cloud to where it might hit the ground. And so you don't really want to be outside during a thunderstorm, even if it seems like the lightning's kind of far away. And also, if you need to get into safety, you know, to go inside a house is the best choice, but maybe you're out of that baseball field that I had there and you can't get into a building or anything like that. And if you get in your car, it's basically a Faraday cage, a nice metal container, and the charge will pretty much flow over it. Now, it's going to may cause some issues for the electrical systems of your car, but as far as being electrocuted on the inside of the car, you're going to be fine. All the charge will move around on the outside of that car and down into the ground safely away from you. So just a few things about lightning, kind of how it works, and obviously it's very dangerous, so you want to be aware of ways to avoid it if you can.